This is the official release dashboard for XOOPS 2.7.1. It marks the final iteration in this cycle of the open-source CMS. The core objective of this release is a deliberate shift in the server environment. XOOPS is moving away from legacy constraints to establish a strict, enforced baseline of PHP 8.2 or higher. This update executes a structural bridge, connecting a two-decade-old software architecture to the rigid requirements of modern enterprise hosting. We can map this release across three specific architectural pillars: defense in-depth security hardening, the decoupling of core dependencies, and the enforcement of strict user interface contracts. For legacy platforms to remain viable in modern environments, incremental patching eventually hits a ceiling. Foundational architectural enforcement is required to process data safely. Historically, monolithic legacy setups operate on perimeter-based trust. They rely on deeply entangled code where data flows freely once it passes the outer wall. Moving from a single outer boundary to a defense in-depth model with nested membranes filtering requests. Under the old monolith, one outdated library bottlenecks the entire system. By decoupling dependencies, individual components iterate independently, allowing efficient upgrades without risking core stability. The 2.7.1 release fractures the monolith and enforces modern boundaries while preserving backward compatibility for existing modules. To understand how this works in practice, we start at the lowest level of the architecture, the database interaction layer. Legacy core systems frequently handled database mutations and dynamic queries with broad permissive methods, creating a significant surface area for injection exploits. Look at this base grid. For database writes and data definition language, the legacy queryf call is deprecated and removed from the active pathway. It is replaced by exec, a strict execution method reserved exclusively for state-changing queries. Concurrently, the system abandons the older quote string method, shifting entirely to quote for modern data sanitization. Because this relies on the PHP 8.2 baseline, strict typing rules are enforced on these query methods. The code will reject invalid data types immediately, preventing silent failures or type coercion. Modernizing query execution at this foundational layer eliminates entire classes of injection attacks before the data ever reaches the application logic. Moving one level up the stack, we hit the security perimeter, managed by the newly integrated Protector module wrappers. As shown here, Protector actively inspects query wrappers, blocking directory traversal attempts at the border. This perimeter defense applies heavily to the upgrade pathway, strictly requiring administrator group membership. During the apply patch sequence, the system mandates a valid cryptographic security token. Furthermore, all upgrade SQL dumps are forcibly isolated and stored outside of the public web root, ensuring configuration data cannot be scraped. Public interaction points receive similar hardening. The Tell a Friend form now executes persistent per-IP rate limiting alongside CAPTCHA verification. Security operates as a structural component baked directly into the file hierarchy and routing lifecycle. Beyond threat mitigation, the architecture addresses system bloat and dependency management. Bundling heavy, specialized development modules within a production CMS core creates unnecessary weight and complicates standard updates. To resolve this, 2.7.1 extracts the debug bar module. Watch as it detaches from the core and moves into a standalone repository. The underlying PHP debug bar library remains bundled in XOOPS lib. This thin tether ensures users avoid a secondary composer installation. This specific extraction allows the development team to push Bixense to debugging tool immediately, rather than waiting for a full core release cycle. System maintainers must note, a standard overlay upgrade will not automatically delete the old bundled debugger bar files. They must be removed manually to avoid executing legacy code. Extracting non-essential components reduces the attack surface, enforces modularity, and streamlines future maintenance. Finally, we reach the topmost layer of the system stack, the presentation and UI rendering engine. Historically, third-party legacy modules utilized vastly different form rendering logic, leading to inconsistent visual layouts across sites. The solution is the XOOPS Form Container interface. This grid visualizes its function, formalizing a strict shared contract for all form containers. The interface connects back-end logic to modern front-end framework templates, forcing the output to conform to the established standard. This enables the integration of current presentation tools, including the Alpine JS-powered X Tailwind theme and the updated X Bootstrap 5. These supplied themes now include native dark mode support, utilizing Smarty 4 and 5 extensions registered across the rendering engine. Formalizing the UI contract ensures that complex third-party modules render predictably and securely across any modern theme. Moving from theoretical architecture to practical deployment requires a strict execution path on a live server. For legacy maintainers, the prerequisite is absolute. Older sites must upgrade to the 2.5.11 baseline before attempting the 2.7.1 migration. This flowchart maps the required sequence. The critical step is the execution of the preflight.php script. The preflight script specifically identifies and flags Smarty 4 template incompatibilities, requiring resolution before the main upgrade executes. A stepped, rigorously verified migration path is mandatory to safely bridge monolithic legacy data into a strictly typed environment. From strict database mutations through the defense in-depth perimeter up to formal UI contracts, the stack is fully restructured. XOOPS 2.7.1 successfully rebaselines a legacy platform to meet the demanding requirements of enterprise PHP 8.2 environments. This data flow follows the new routing lifecycle. The system isolates threats at the perimeter, allowing verified traffic to pass through strict validation layers. Enforcing these rigid architectural boundaries secures the platform's legacy against modern environment requirements.